I worked as a designer creating packaging, and I realized that I was basically making beautiful trash. Like great products, but the packaging was plastic and it was trash. So it became this sense of, I know that designers hold this immense power to make things gorgeous and engaging and irresistible. Can I pivot and channel that energy towards better materials? At Sway, we use seaweed as a replacement for plastic. And we've created a system that works on traditional plastic infrastructure so that we can work in partnership with legacy industry to have them start running plants and seaweed on their machines, and also create more compostable materials that don't require special facilities but actually can compost in your own backyard.
Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hardware to Save a Planet is brought to you by Synapse. Make sure to click subscribe so you don't miss any future episodes. Thanks for listening. Hello and welcome to Hardware to Save a Planet. We are recording live today in front of real people in, woo! Thank you. We're at Capgemini's San Francisco Mission Rock studio during San Francisco Climate Week, having an awesome conversation about the ocean and plastic. And I'm really excited for this next conversation. Really quickly, I'm Dylan Garrett. As Miguel said, I lead Synapse, which is Capgemini's hardware innovation studio here in the US. If you don't know the podcast, we started it a few years ago to highlight the physical technology innovations that are having an impact on climate change or will in the future have an impact on climate change, and the people bringing those innovations to life. It's a really fun show. I recommend you check it out. We've had some awesome guests. I'm really excited about this today. The people up here with me are at the forefront of the solutions to the plastic problem, helping us to develop and use materials that replace plastic and actually benefit the environment, which is pretty incredible. Let's see, we have Julia Marsh here from Sway, CEO and co-founder of Sway. They produce seaweed-based plastic alternative materials. There you go. Visual demonstration. Thank you. They're home compostable, tackling, at least initially, plastic films and bags, which is a massive problem. We'll talk about more. Molly Morse, co-founder and CEO of Mango Materials, which uses methane emissions to create biodegradable plastic alternatives. And then we have, yes, thank you. Ryan Starling from Frog Design. Ryan uses design to influence how and when plastics are used in our products and how people behave around plastic. So it brings a really helpful perspective. Thanks everyone for joining. This is a topic I personally think about a lot and care about a lot. I have little kids. I think a lot about how to reduce plastic in their lives, how to reduce the amount of microplastics in their future world. And I got to say, as an individual, it's a pretty daunting problem to get after. We were just sort of talking about this. What do you do as an individual against something with such a crazy scale? So it's really awesome to know that there are people like these three tackling it at a higher level. Just to quantify that really quickly, the production of plastic is where most of the emissions come from plastics entirely, which is around 2 or 3% of global greenhouse gas emissions are from plastics production, which is pretty insane. And we heard this earlier, 19 or 20 tons of plastic waste goes into the ocean every minute. And that's only a small portion of all plastic waste. So let's get into it. For people in the audience, we're going to have a little bit of time for Q&A at the end, hopefully. So hold on to your questions and we'll do that when we wrap up. I want to start with Julia, if you can. Tell us about the moment in your life when you knew you wanted to dedicate your time and energy to the plastics problem, and then give us a little rundown on what Sway does.
The year is 1998. I'm a child in a tide pool in Monterey Bay with my little sister, and my dad is saying, you got to leave it better than you found it. And there's a candy wrapper in the tide pool. And we're like, that doesn't belong there. And the hermit crabs are our friends. And it was a very personal connection from the beginning. Dedicating your career to it is a different story. I worked as a designer, creating packaging. And I realized that I was basically making beautiful trash, like great products, but the packaging was plastic and it was trash. So it became this sense of, I know that designers hold this immense power to make things gorgeous and engaging and irresistible. Can I pivot and channel that energy towards better materials?
Nice. And describe quickly what Sway's solution is.
At Sway, we use seaweed as a replacement for plastic. And we've created a system that works on traditional plastic infrastructure so that we can work in partnership with legacy industry to have them start running plants and seaweed on their machines, and also create more compostable materials that don't require special facilities, but actually can compost in your own backyard.
Thank you. Molly, same question for you. Go for it.
Similar to Julia, I was a small child. I think in second to fourth grade, I had a bunch of experiences. Like an activist came to my elementary school class and talked about recycling. And I got very, very passionate about recycling. And I went on a field trip actually to the Monterey Bay Aquarium, like near where Julia's from, with my fourth grade class. And there was an exhibit about plastics in the environment. And it just blew my mind how much plastics ended up in the ocean. So this has been, sort of a lifelong passion of mine. When I was an undergrad, I took a class called Introduction to Solid Waste Management, which we just called trash. And basically there I learned that unfortunately we're not going to recycle our way out of this problem, which we totally should all recycle. I'm a huge still advocate for recycling, but the problem is just so huge. We need other solutions. So I was a PhD student, a sort of accidental PhD student. I'll spare you the whole story, but studying biodegradable materials. So we were trying to replace plywood for construction and became very interested in biocomposites, where you use natural-based glues with fibers to replace plywood. Became very interested in different kinds of glues, these plastic polymeric materials. I'm very passionate about this one type of polymer called PHA, or polyhydroxyalkanoate. It has unique mechanical properties and also widespread biodegradability properties. So the pathway, PHA, is made by almost all living things on planet Earth, from bacteria to humans. And because of that, the enzymes needed to break down this polymer are very common. So if we want to address plastic pollution or widespread biodegradability, PHAs are a unique way to do that. And so that was my PhD research. I was a technical engineer, and after graduating saw all these other people starting companies, and I was like, if they start a company, why can't I? So incorporated Mango Materials with my two co-founders, and our vision is to transform how plastics are produced. So we use bacteria and also what happens when they're no longer needed, end of life. And our unique take on PHAs, so you can make PHAs from almost anything, humans make some of them, but bacteria, the way you industrialize this generally is using sugar. You take sugar, feed that to bacteria to produce PHA inside their cell walls. And we do purchase PHAs from others that do that. But we also have a unique way to make PHAs using methane emissions. So we use methane emissions from the Vacaville wastewater treatment plant. So this methane would normally be flared. It's a greenhouse gas. And instead of flaring it, it comes into our fermentation tanks where our bacteria live. They eat the methane, kind of like how we would eat chocolate, and they accumulate the biopolymer inside their cell walls, which we then harvest and use as a replacement for plastic.
And I asked you this earlier when we first met, but I thought it was a pretty cool answer. What is the LCA for your materials? The life cycle analysis. What's the sort of
it's a great question. I like to go too technical, but it really depends on how what would happen with your methane. So in Vacaville, if we're not using the methane, it is all flared. So comparing it to the candle flare, you're sequestering about -8, -9 kilograms of CO2 per kilogram of material you use. Now, instead, if you're partnered with an agricultural facility that's venting it, or abandoned coal mine where it's being vented, it could actually be almost negative 80 kilograms of CO2 per kilogram of material sequestered. When you're just like, it's because methane's a very potent greenhouse gas, way more so than CO2. And so in terms of LCA, you get more bang for your buck.
Which I think is pretty cool. By producing your material, you're actually sequestering.
That's why we're huge advocates of methane, and I love to talk about it.
Ryan, tell us about the time you were in Monterey Bay and how that motivated your...
I was going to say, I love that you picked chocolate, which I'm definitely fueled by chocolate over here. No Monterey story. My journey to awareness started much later than either of you. And, I got into this career in industrial design because I love stuff, cars and bicycles and, speaker systems and stuff like that. So I was in school for this, and this was the era of creaky plastic phones. Probably most of you have had one of these, the Nokia brick, the Motorola StarTAC. And it was sort of a desire for me, an aesthetic desire to make things feel better. And be more durable in our hands and in our pockets that got me into this career. And it was when the first iPhone was announced and it was made of aluminum. I was like, this is the way to go. This is where this is what our product should look like and feel like. And that drew me into the career, drew me out to California to be in industrial design and product design. And, as I got into that and saw sort of the state of what our alternative circular or sustainable materials was very poor. You would see these ecological options that had weird filaments coming through them. You had to work with the aesthetic of these unusual materials. And I also, as I got into my career designing, learned that the decisions around sustainability are much more complex than they appear on the surface. It's not just, well, let's make that out of aluminum and glass instead of plastic. But depending on how many times the product will be used, how long it will be in circulation, you have your carbon impact to deal with, along with considerations of environmental toxicity. And so my professional career has been this long journey of understanding those trade-offs, learning how to leverage LCA, kind of grok what's most important from the LCA, and which numbers are really hard to anchor to, and figure out, how can we make this product that it's going to be aesthetic, people are going to enjoy using it and hang on to it longer, so that it's a truly sustainable product sort of from cradle to grave, not just in the Excel spreadsheet of the LCA.
And that kind of desirability of products, I think, is a really important point. Hopefully we'll talk about a little later, the challenges to scaling these solutions and adoption of these products is a big part of that, I'm sure. Julia and Molly, if you can help me, when you think about the positive impact your solutions could have, is it... I see that you're innovating both or you're changing the story both on the production side and end of life. Do you think that the impact you're having is bigger on one side or the other? Is there a way to think about what you're doing in terms of emissions reduction, and is that the biggest story, or is it about end of life and biodegradability, or is there a better way to think about it?
I like to think we have equal impact on both sides. At the beginning of life, we're working with ocean farms. So there are about 35.8 million metric tons of seaweed being cultivated around the world. And that's separate from the wild seaweed that's growing. There's 100 million plus metric tons just naturally growing. So we're working with these ocean farms. And as seaweed's growing, it's sequestering carbon. It is absorbing polluting excess nutrients. It's creating habitat for biodiverse life. It is balancing our climate just by growing. And then seaweed farms provide millions of jobs to coastal communities all around the world. So all that goodness is baked into the material itself. Seaweed's also super diverse. There's 10,000 plus species. It grows faster than corn or sugarcane. It doesn't need fresh water. It doesn't need fertilizer. So it's really light at the beginning of life. And then by turning it into a compostable material, we're tackling this issue of polluting plastics. And you have a material that decomposes completely with no microplastics or toxins. So I think that the benefit, probably the biggest one, is the biodiversity contribution. And then the other is the economic opportunity, both for blue jobs along coastlines, and then also green jobs within American manufacturing and switching over to new materials. So yeah, I would say holistic impact from sea to soil.
And just on the seaweed point quickly, is there something specific, is there something unique about the sort of properties of seaweed that make it particularly suitable? Understandably, it's a very sustainable crop to grow, but is there something about the mechanical properties that selected it?
Yeah, seaweed contains natural polymers. So if you imagine seaweed growing in the ocean for nearly 1 billion years, it's been battered around by ocean tides, and it had to develop plastic-like qualities. If you ever pick up a piece of seaweed on the beach, you'll know it's really stretchy. And that's because it has polysaccharides in it, agar, alginate, carrageenan. There is an underwater industry dedicated to processing seaweed to get these natural polymers to create products that we use every day. In our lotions, in our donut glaze, it's a stabilizer in beer. It's all over the world, and that's the same component we use to create our plastic replacements. It's durable, it's flexible, abrasion resistant, grease resistant, all kinds of great natural properties coming from the seaweed.
How about you?
What was the question?
When you think about the impact you're having, is it more about the production side, the end of life?
I'm sorry, I was so enthralled with Julia's narrative.
It was good. It was good.
Yeah, so our number one mission of our company is end of life, is addressing polluting plastics. So early on, we used to say that was the key focus. And then our gift with purchase was the methane sequestration, carbon sequestration side. But over time, that sort of pivoted, just because now that we've learned so much about methane, and often these waste sources from wastewater treatment plants, landfills, agricultural facilities, this methane isn't used. It's not like we're competing with somebody else, although we do have exclusive rights to the Vacaville wastewater treatment plant methane, but like we need a lot of other uses for this methane. So I'd say they're both important, and similar to Julia, like we have a different manufacturing process, but we envision this world where you could produce your materials locally. You know how there's like a movement to have local food or whatever. Well, imagine wherever there's people, wherever there's methane, there can be anaerobic digestion to methane. People, animals, plants, anaerobic digestion to methane, and then methane to PHA to make our materials locally. And then we can make our packaging. I mean, that's the long-term utopian ideal here, is that then we could use the methane to make our materials locally, and then PHAs are anaerobically biodegradable. So you can take your food waste, you can take your PHA packaging, you can grind it all up, you can put it back in the digester. By the way, in the US, we have a lot of extra digester capacity, including in Oakland. So we can use that for our food waste and all our PHA waste, put it back and make more methane and use that methane to make materials, or you can also do fuel and other things with it. But this is our long-term vision for this decentralized, like resilient ecosystem, if we're going to just dream big there.
So you've made these materials that are way better for the environment and actually at least less harmful, if not good for the world to be produced. The question I keep having is there a risk here of moral licensing? In other words, would it be better overall to focus all of our efforts on reduction of plastic use and changing the way we behave around plastic, how pervasive it is in society, and does having a better, very plastic-like alternatives to plastic complicate that message in some way and slow the efforts down?
I mean, we've been trying to do that since I was in second grade, and things haven't really changed.
Yeah.
So unfortunately, for sure, we should definitely reduce. We should reuse 100%. We should recycle. But unfortunately, that's just not enough. And I mean, sometimes I get the argument of people say like, oh, well, are you perpetuating a single-use mentality or something like that? And so that is something I think about. Like our products don't generally go in there. We're doing things like, I mean, some fashion, some beauty, arbor stakes, some things like that. So it's not exactly like that sort of mentality, but similar to sort of how we introed with like the water after the floods or what have you, like there's a lot of plastics that are really important for hygiene, for long-term health of our species. And so I think, the big challenge is how we scale up these kinds of solutions and how we get them ubiquitous. And yes, and at the same time, like all the NGOs who are working to bring these amazing stories to the forefront to make the next generation of Molly and Julia's, and I guess you weren't in second grade when you had this experience, but it's like, getting all of those, getting that awareness out there so we can all, help rise all the boats. And it's going to take a lot of time and we need a lot of solutions. So yes, reduce and reuse, but it's not something I really lose sleep about, that I'm creating a alternative that might be perpetuating a single-use mentality.
Fair. Anything.
Talking from the designer's perspective, I think there's some projects like in when we do packaging design, there's some projects where the answer is kind of easy and obvious with the tools we have available to us. It's like, well, we can replace everything about this packaging with paper. Not a problem. That paper has a really robust recycling supply chain, and maybe depending on where the paper is sourced from, maybe good credentials in terms of carbon footprint as well. But there are other applications, maybe that packaging is for a medical device and we have certain sterilization considerations that we need to maintain. And so then that's a kind of a single-use application where there's really not a better solution than plastic. So having these newer alternatives is a really powerful tool for us. That doesn't mean we can't also leverage other circular or similar solutions.
Yeah. I would build on that, which is design for reality. And the reality is there are billions of dollars of infrastructure globally dedicated to the production of plastics. And so a big portion of this is to align the incentives and to have a new material that can be produced on those machines. And I think I started in this career so bright-eyed and hopeful, like, we can do this. It's like, no, plastic isn't really going anywhere, honestly. And the people in this room and the people listening to this podcast are very special that they care. Most people don't care and they don't know. And so it's up to us to create materials that are easy to adopt, that are easy to manufacture, while also doing the good work of reducing consumption and making it harder for people to create waste.
Can you talk about that, where you're at on that journey so far of getting people to adopt this and getting it manufactured on that equipment you're talking about? What are the first kind of applications of what you're producing? Where is this out in the real world?
I can start. We're really focused on flexible plastics. There's about 180 billion plastic polybags used in the fashion industry every year, and that's just fashion. 5 trillion plastic bags, wrappers, pouches produced every year across industries. So this is a category of packaging that's huge, and then less than 2% are recycled. It's lightweight. It gums up machines. It floats out of the dump and into nature. Represents a huge portion of plastics that show up in nature. So we're working primarily in bags for shipping and shopping with fashion brands like J. Crew and Burton, with personal care brands like Dr. Bronner's to get these plastics out of their supply chains. And then over time, our dream is to get to food packaging where we don't want toxic plastics coming in contact with our food. And that kind of packaging is really unlikely to end up with a reusable solution. So that's our focus right now. We launched last year officially. We're already at commercial scale. And we're not going to stop scaling no matter how hard it gets out there.
So our number one focus is injection molded goods. So this is more rigid type applications. Our very first commercial partnership was with a Brazilian B Corp called Natura. They make beauty care products. So it was packaging for a soap dish. We also have in Allbirds, I guess they're not around anymore, but a program that has their zero carbon shoe of the future. We have a product in there. One of our largest customers is actually in the arbor industry. So when you plant a baby tree, like for a landscape project, often you'll have wooden stakes. And instead of having the wooden stakes, you can secure the root bulb underground using PHA-based stakes, and that way it biodegrades as the tree gets bigger, and then you don't have to send a landscape architect back out, or you don't have to specify to retrieve those stakes. So these are the sort of applications we're mainly focused on, although I do also love me some PHA 3D printed filament. There's really strong adhesion between layers, so that's a really fun kind of specialty application, but maybe a little nerdy for this audience.
Can you say something about what is motivating your customers at this stage to adopt your materials, and are they making a trade-off to do it? Are they paying a green premium? Are they accepting lower performance in the properties of the material? And how might that change over time?
Yeah, sure. So PHAs melt and flow similar to existing plastic. So you can use conventional equipment on them, but they do melt and flow a little differently. So you just have to be prepared for that. Our current scale is that we do charge a higher price compared to existing plastics. And if there's one key challenge here, it's that. It's that a lot of big, huge corporations can only pay what they pay for existing plastic, and that's produced at billions of pounds at a single location. It's been so engineered for decades, and they want us to match price. And it's like, okay, here we are with our 5,000-liter gas fermentation system at the back of the wastewater treatment plant trying to support a business. That's the whole problem. So these first applications tend to be in fashion and beauty. Oh, also, Stella McCartney has some sunglasses made out of her material. So and for her, actually, it's a carbon story. It's a methane story. It's a climate change story. That's what matters for her. Same with Allbirds. It was a carbon sequestration story. They wanted to be the zero carbon shoe of the future. In order to do that, they needed our negative LCA to help with the other materials so that they could publicize this. So it's a marketing story. In terms of performance, no, there's nothing. It's a little different, but there's nothing inferior. And actually, for something like 3D printing, you get, compared to PLA and others, you get something better. But so the customer base and the need for why they're using our material is really different. So for instance, in arbor stakes, it's a very specific performance they need with a very specific tuned biodegradability that only our material can do. And not only that, even my PhD was in biodegradation, so we have a unique way to tune the biodegradation. So even amongst other PHA companies, we're unique like that. So there, it's a performance benefit.
Similar, or would you add anything to that?
For us, it starts with a customer demand point, usually, which is I ordered my gorgeous sweater and it came packaged in plastic, and this is kind of just gross and lame. And why are you guys doing that? Mm-hmm. The second is performance. So your customers can want non-plastic packaging, but does the product perform? Our material performs just the same as plastic in the necessary ways. But then the third reason is compostability allows these brands to comply with emerging extended producer responsibility. And again, yeah, it is. It's a great story. The cherry on top is, yeah, we're working with these regenerative ocean farms. And for every single bag, we can trace the carbon sequestered by that seaweed that's in the bag. We can trace the biodiversity contribution, the pollutants that were removed per bag, as well as how many acres of ocean are protected from that bag. It's so cool, down to the bag level. So I think, yeah, holistic again, but it starts with customers want this and the product does the job. And we're already less expensive than other compostable alternatives. So if a brand is on this track, it's a pretty easy choice.
And Ryan, you're often on the other side of this conversation, right? Helping companies think about what materials they should be using. What does that look like?
Yeah, I mean, I think price is one part, but as a product designer, usually we have levers to help with the price. We can trade off the material that we're using, the alternative plastic, with something else to keep the target price for this product where our client wants it to be. But some of the, I have gone to some clients with 5 or 10 ocean-bound plastics, plastic alternatives, like a whole list of materials that I would like to use instead of what they're used to. And the challenges that I will see with that is, first, show me all of the testing for not just mechanical properties, but degradation, UV resistance, chemical resistance, et cetera. And I can gather that sometimes from younger companies. That's not all done yet. We can work on that and try to get it together. But then even then, I will still meet resistance sometimes because they will say, well, I have this current polymer that's been in field for 15 years or for 20 years. I know it will last. And I'm not convinced, that these alternatives you're bringing me will last. So that's been my big obstacle. I think, a sort of a swap to a material they're already familiar with that has performance in the field for them that I can usually get away with. Introducing something new is trickier.
So it sounds like the kind of the scale of the incumbent industry and the cost and the quality of plastics today is really like the big challenge to overcome to get to the kind of impact we need to have with these sorts of materials. I want to dig into that a little more. I imagine there's a scaling challenge on the supply side and on the demand side to get to a place where everybody wants these materials. But on the supply side too, like, can we farm enough seaweed in the world to create 5 trillion plastic bags? And is there enough waste methane? And what I'm curious, when you think about how do you get from here to the sort of scale you want to have an impact, what are the biggest challenges you see ahead of you?
Yeah, so I'd say the biggest challenge is both on the demand side. So just like all this education, which is why it's great we're doing this podcast, because then maybe your potential clients would hear this and be like, oh no, I'm familiar with seaweed-based and PHA-based materials. So that's the dream. So yes, having more demand, that definitely helps. To answer your question, there's plenty of methane. So even the largest wastewater treatment plant in the US could produce almost 1 billion pounds of PHA per year. And so, and if you look at all the wastewater treatment plants and landfills, we're talking billions and billions and billions of pounds of PHA. So that's not the challenge. The challenge is to have the demand, have the capital there, and everything else. These new materials, there's a lot of confusion on end of life. There's confusion on, because there's some polymers out there, or there's like a biological route to polypropylene or polyethylene. Like you can use that biologically, and you can use biofeedstocks even in portion for that. Like that's what the Coca-Cola plant bottle is. That has nothing to do with end of life or biodegradable. It's the exact same polymer, but kind of like what Julia was saying earlier, that nobody cares. Like, oh my gosh, that's so much education. So it's like, okay, you can have biological feedstocks to make something that's not biodegradable. And then you can actually use ancient fossil fuels to make something that's biodegradable. So, okay, then you're using like ancient carbon to make something biodegradable. In our case, in both our cases, we're using bio waste, something biological, and we're making something that's biodegradable. But this is just really, really confusing. And so if we need the demand, we need this huge volume so we can build the big plants, and the capital to do it. Yeah, incentives help.
I would say confusion is a big barrier. And even within the space of super uber educated folks, it's so confusing, and folks don't want to embrace nuance. And there's a lot of inertia behind plastics and plastic recycling. And there's money in the pockets of the folks who are in the rooms where we're negotiating shifting away from plastic. It's just crazy. So actually, biomaterials are up against a separate challenge, which is that folks, honestly, I think, are incentivized to promote recycling.
Oh, 100%.
It's a big problem.
Double tap on that. Double tap on that, please. Because people are like, oh, we should just have one polymer. We should just make everything polyethylene. Then we can recycle it all and we'll have the perfect flow. Do you know how many times I've heard that? I just bang my head against the wall. Be more efficient. We want more policy that incentivizes the use of biomaterials and makes room for new materials, because if I can go a little bit deep, a little bit. Do it. Okay.
Go deep.
A little bit. Right now, there's policy emerging within California that will probably inform the entire United States approach to extended producer responsibility, where we are discouraging the use of compostable packaging going into compost, because compost is a business to create compost. It's not to promote the processing of waste. And so now we have new materials being invented that are truly compostable, that pass the gold standard for compostability, that will be rejected from composting because composters don't want foreign materials in their product. So we have to have nuanced conversations and invite everybody to the table, or we're not going to have a place for all this compostable packaging to go.
And it has to do with the certifications. So they actually sometimes can't accept the material because they can't sell their compost as organic compost, which is what they need to do for their business. And so there are these rules saying if you accept anything that looks like a polymer or plastic or whatever, you can't be certified organic compost. So that's where this is all coming from.
Composters, are you listening?
I mean, everyone's just trying to do business, right? So like, I don't think they're not fundamentally anti seaweed or PHA materials. It's just they need to be able to sell organic compost. And if the certification says they can't, then they won't.
That's currently the biggest barrier.
Well, luckily we have a lot of composters that listen to the podcast. So yeah.
Yeah, we're circling back to the question earlier around how do you storytell about this, right? And it's like, honestly, the ocean plastic problem is a very visceral image that's compared to the complexity of what polymers can be recycled, what can be biodegraded, what can be home composted, what can be commercially composted. That's a much, much thornier, more complex storytelling, piece of storytelling that you can't put the image up that people understand.
We got 5 minutes. I'd love to take questions from the audience if anyone has any.
Thanks. Hey, I think you started down this path a little bit with health, but since you're playing in a rigged game, at what point do you just go all in on traditional plastics are bad for your health instead of just focusing on LCAs?
Yeah, we do that. So we actually have a direct line of sandbox toys that we sell on our website specifically for that. So you can not only educate your child and they can play with a sandbox toy that if it accidentally ended up in the ocean wouldn't last forever, but also addressing the health. It's like non-toxic, it's phthalate free. It won't harm it won't create these harmful toxic microplastics as part of it. So actually, we haven't really talked about like microplastics or that aspect on this panel, but that is a huge thrust of what we do, and in part why we're not a toy company, but we did that specifically for the messaging.
Yeah, for the first time in history, maybe plastics or microplastics are a bipartisan topic because microplastics impact fertility. Both Sway and Mango are featured in a new documentary on Netflix called The Plastic Detox, which showcases the direct correlation between plastics and lower fertility rates, and then introduces natural solutions as alternatives. So yeah, absolutely. We can reach across both sides of the aisle with this narrative around human health.
I'll just jump in that I've been full circle on this issue, and I think not actually even sure where I am right now. I think when you look at the product, the plastics problem in isolation, it feels like an easy answer to say, yeah, let's just not do petroleum-based plastics. But when you look at climate change as well, there's a lot of times when the plastic solutions are much, much better in terms of your carbon emissions and our short-term, need to keep temperatures down. So it's a thorny issue.
Hi. I have a question going back on phthalates. So I know that we talk a lot about microplastic and how they're toxic, but there's also like all the additives that are added that we don't really talk about. And I was wondering, I know that, for example, PLA and some bio-based plastic actually have additives that are toxic and that can leach. And I was wondering, what's your position with that? And if you consider adding additives to your product to make them maybe more flexible or harder or UV resistant and all of that.
Yeah, so it's a super tricky topic. So first off, PLAs don't necessarily have phthalates or any additive. It depends how it's formulated afterwards. So for similar to polypropylene or polyethylene, there can be thousands and thousands of formulations. And yes, you could use, with all that kind of stuff, our solutions as well, you could mix it with all sorts of crazy, terrible things, like fluorinated backbones that are going to last forever and be bad. And so not all PLAs have that. So we do our own formulation and we don't do any of that. Everything we do, and we do use other materials to formulate. And like, we've never blended, I don't think, our materials together, but it's possible we could and get interesting properties, and that's formulation. And so maybe you want to do that, like you said, to make it more flexible or what have you. At Mango Materials, we only use ingredients that could be completely marine biodegradable. And by that, also biodegradable is a little bit of a tricky word that I should be careful when I use, because generally I like to say prone to enzymatic attack. because biodegradable is a whole can of worms, because it's like whenever someone says biodegradable, just quick side note, TA Molly over here, you should know what environments it's in, how thick it is, or the format of it, and in what time frame, what rate. So like everything's biodegradable somewhat, but maybe it's biodegrade 1% in 1,000 years and it's this format. PHAs generally mimic cellulose. So similar, if you have a leaf and you put it in your garden, it'll biodegrade fast. If you have a log and you put it in your garden, it'll biodegrade slower. If you live in the tropics and you have a leaf, it'll biodegrade really fast. If your leaf sinks to the bottom of the Arctic Ocean, it's going to actually maybe take years to biodegrade. So anyway, biodegradable means prone to enzymatic attack. Sorry, I didn't mean to be entertaining.
Keep going. This is great.
Part of this. This is why I like no drinking and talking about biodegradability. Anyway, and which I didn't. But yeah, and so anyway, it has to do with the formulation, and not only that, but so we work really, really, really hard on our formulation. We have very amazing team members who do this. It is possible that we make this great material. Like we have a fiber grade, and I have a sweater, I'm not wearing it, made out of PHA fiber. It would be possible that we've done all this amazing work and someone comes and puts a fluorinated coating on it or some kind of color. So we currently have like 8 colors that are, and colors are hard. And we're super proud we have 8, but maybe they want a color that isn't easy to make and they put some toxic color. So it's not necessarily the fault of the raw material. It has to do with formulation and the whole long supply chain. And that's why, yeah, maybe we get more jaded over time or something. I don't know.
Amen.
Prone to enzymatic attack. This is what we have to say.
That's what I like to word. I try not to use biodegradable, but it's just biodegradable is a more ubiquitous word.
We'll work on that.
Yeah. Hi, thank you guys for this talk. Very interesting. I had a question about ecology on 2 fronts. One, we talked like a little bit about microplastics, right? And thoughts on the ecology of what's being affected in the environment through that. And then 2, what would be the effects of bringing in a new polymer that's more biodegradable and how that would affect like, shifts in microbial community or fish or kind of other areas of like soil, that type of thing.
So I'll try to keep it quick. So PHAs biodegrade, they enter the naturally occurring carbon cycle. So it's similar if we're to eat some kind of food and it goes through us and some of it gets digested, some of it gets released as heat, some of it is waste, some of it is respired. Same exact thing. And so in terms of the ecology, one of the side effects of biodegrading PHA generally in an aquatic environment is it does pull nitrogen out of solution, which can actually be a good thing because that's why we have algae blooms and what have you is from excess nitrogen. Maybe in your soil, if you had high levels of PHA, you don't want to be pulling nitrogen out of your soil. So maybe that wouldn't be good, but you would need a whole lot of PHA in your soil in order for that to happen. But in terms of the microdiversity, like it depends on the volume and any kind of feedstock is going to change. Like bacteria are going to grow and flourish where there's certain types of feedstock, regardless of the material.
Good. Okay. Well, yeah, go for it.
Hi. Thank you guys so much. It's great to hear from you. I just have a question on, all of this really innovative design. How do you balance disrupting all of these systems and creating these new creative ways to attack these problems with making your work metabolizable to the general public and the people who you work with who are kind of resistant to the idea? I know that I've worked in, fashion packaging before and tried to tackle okay, you really don't need this extra plastic bag. You don't need the 3rd layer of plastic, and have gotten exclusively resounding no, we cannot redesign this. We need to protect this. So how do you metabolize that for the people who need to make the big changes?
For me, that's, the learning over the course of my career has been that you have to engage those stakeholders really early on in the process. And also a lot of times your own client won't know who those stakeholders are. So a lot of times it's actually folks in the warehouse, in supply chain, in operations who say, well, we don't want to change how we're wrapping that cord, or how we're storing those units that we need to load on a order by order basis into the primary packaging. And so, I have to make sure that I tell my client who through their entire supply chain is going to need to be made aware of these design changes, and that they are able to get them into the loop so that we're socializing the design with them. And so like when it comes to packaging work, we'll engage operations, and then we'll bring a mock-up of our new design to the warehouse, and actually, run some tests with them so that they see, okay, this is changing my process, but I'm comfortable with how it's changing my process. I think the other way that you have to Trojan horse it in there is by making it a part of their brand story. And sometimes this goes well, sometimes it doesn't. But you can, in the beauty space, you can often get buy-in on something like glass as an alternative to plastic because it's more premium, because it tells a story about the product. And so it's just about finding like, what are my little ways in to sell something that is a more sustainable solution as something that the customers of this company actually want to buy.
And can I give a little case study for both those points? Because that's exactly what I would have said, Ryan. It's working directly with the procurement or the guys who are on the warehouse floor. We were working with a client who wanted to switch their Amazon packaging to our material. And the team was like, no, it won't work. Amazon's so brutal. It can't hold up. Seaweed, that sounds weird. And then they got our bags and they tested them and they worked. It's like the proof's in the pudding. And they're like, okay, this is fine. It works. I'm on board. And then the other example to the brand story is, if this is going to accelerate the goals of multiple teams within a company, it's way easier to get buy-in and budget. So if a brand that we're partnered with, for example, there's a brand that makes shorts out of banana fibers. They're called Alex Crane. And they wanted a story for their packaging that mimicked the beauty and the importance of the shorts. And then they got to advertise that on their online shopping. And they saw a dramatic uptick in sales when it was packaged in Sway versus not. So a full, complete story all of a sudden completes the brand image.
Love that. Any other questions? Bring them to happy hour. After this, we're going to wrap up. Julia, Molly, Ryan, that was really fun. I learned a lot. Thank you for all the work you're doing. I'm rooting for your companies. And thanks, everyone, for joining us.
Thank you.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.